Okay, hi. So this is just a quick introduction to the Music Box installation that I've created for Reach Art Studio and Community Music School in East Lansing, Michigan. This project, or at least this portion of it, is going to be installed inside of a giant box with a keyboard and some speakers embedded into a statue of birds surrounding a bird bath. And so this is just a quick demo as to how it works. Everything is on the computer. It's currently running off of a Raspberry Pi that is booted into Linux. Everything goes through that USB hub, and then from the hub it splits out. We've got a Griffin iMic that is attached to a really cheap computer microphone, and to a couple of buttons that are attached to this keyboard, and finally to a Korg Nano key. So everything's set to automatically boot, and once it's ready you can play the keyboard, and doing that you get this sort of toy piano-ish sound that I've spanned out across the entire 88 key range. I've also got this button here that if I press it, it records into a buffer that gets picked up by the microphone, processed, and output, and eventually that goes out of the speakers. So all total, I think I spent maybe about $150 on all the hardware, and that's going to go into a very large installation. So here's the next part. This is a much larger example of the code in Pure Data that's shown on my Windows box. The way that this works is that you have these little polyphonic synthesizers here that are meant to emulate a toy piano. Initially I had created a toy piano out of samples, but that led to a lot of problems with buffer overwrites, so, well, can't do it. Basically MIDI goes in, and then I took a design out of Andy Fresnel's Designing Sound book of asynchronous partials. Really not much to them. They just have a couple of abstractions to give them different transpositions and decay times, and all of those occur at once whenever you hit a key. And at the same time it also takes the MIDI and converts that into a frequency that it uses to filter a little bit of noise generation, which is then modulated to a sine wave of the exact same pitch, and it's added to the output before everything goes out. Back in the synth you can see there's an LFO that it receives from the main patch, and every 5 seconds it pans hard left, and then in another 5 seconds it pans hard right, so that you get a constantly shifting direction, which will be really cool when it's coming out of the actual bird speakers that they've built for it. So in the patch itself you can also see that I've got this segment right here, which is a buffer that I'm using to store audio. So I've changed this a little bit so that it's using my spacebar to trigger recording, so that I can grab a mic and show you. Testing, 1 2 3 1 2. Okay, so what that's done is it's taken my voice, it's recorded 2 seconds of it directly into the buffer. Then, because we were worried about kids, throwing swear words or anything else offensive into there, we transpose it up 2 octaves, and it's also played in reverse twice. So there's no way to understand what actually is being said, hopefully. All of that then goes down here and is processed in a Schrader reverb module, again, that was borrowed from the Designing Sound book, and then I modified the variables. But you can find instructions on how to do this on pretty much any Pure Data site. All of those, the synth and the different vocal things that happen, go eventually to this section and our output. And that's basically it. The only other thing is we've got the LFO, which you can see moving here. And we have a little alarm generator that I created that just kind of gives it a little beep code so that you can hear when it actually boots up, because we're going to run this without a monitor. and because that way if anything happens and it needs to send an alarm out, it can hear it. And you can hear it, hopefully, unless the speakers are disconnected. So, I've got this currently mapped out to all 88 keys on my keyboard. You can hear a little bit of it. So that sound is inspired by a toy piano. It has a little initial noise attack and then a lot of partials that are slightly out of tune. One thing that gets kind of cool is that because those partials are ever so slightly out, as you get up here to the extreme range, the partials actually begin to get a little obscured and to be hidden from the range of human hearing because, you know, we're jumping up another 17 whole steps or so on top of that. So what you're hearing at that point is actually undertones that are present in the sine wave modulation but not actually coming through. So kind of cool. It's sort of a non-intentional application of a Shepard scale or something similar to it in terms of the audio illusion. But only in that really extreme upper octave. So, cool. Hope you enjoy it.